Okay, let's start!
Everybody wants to be an ant. Crickets, mantids, my own father circa 2001, hemipterans, beetles, flies, phasmids, etc., etc. Why? Because ants are awesome? Yeah, definitely. But also probably because ants are unpalatable and aggressive. However, perhaps the true presidents of the ant fan club would be jumping spiders of the genus Myrmarachne. I mean, just look at these guys. Not only is their visual appearance almost identical to particular species of ants, but they even behave like ants. Recent studies have shown that these spiders will walk like ants. Instead of the slow, meandering paths of normal jumping spiders, these mimics will go in the brash, continuous lines typical of ants on a trail. However, not all ants walk the same. There's a diverse array of different locomotory patterns among ants. It turns out that ants of the genus Opisthopsis are called Strobe ants because of their stuttering start motion, where it looks like they almost teleport short distances again and again. Interestingly, there are Myrmarachne species that at least visually mimic them. So my question is this: can these spiders that are mimicking the Strobe ants rise to the challenge and kind of have the right moves, or do they move more similar to other ant mimicking jumping spiders that walk like normal, non-strobing ants? It's time for Ants Dance Evolution! Introducing our first contest ant, Opisthopsis hadni, the strobe ant. Its daring mimic is Mimicry bicolor. Representing normal non-strobing ants is Polyrhachis aurea, and its ever-splendid mimic, Mimicry luctuosa. Additionally, we included two larger species of ants in this analysis, Opisthopsis major and Camponotus bigenus. They have same coloration as the putative models, and all 6 species are sympatric, so we thought including them made sense. We recorded these ants and spiders at 240 frames per second, and we used wavelet analysis to extract some features from their trajectories. We looked at the rhythmicity over time, their synchronicity of these movements, the length of a cycle, the straightness of their trajectories, and then how long they spent motionless. We got these variables, combined them in the principal component analysis to see who was similar to who. So if we look at a speed over time graph for these individuals,
Doubles play!
we'll notice that these strobe ants are like a metronome. It's on, off, on, off.
Perfect!
Their mimic is very, very similar. It's awesome. And if we look at the other ants,
Versus play!
we'll notice that normal ants kind of have a very irregular pattern, which is mostly followed by their mimic.
Those are the nicest steps!
However, there are a few periodic and irregular pauses that occur with Mimicry luctuosa. If we look at the principal component analysis, we'll notice that the strobe ants and their mimic are very similar. The non-strobing ants have a bigger spread, and their spider doesn't do quite as well. However, this black and gold is a global mimicry ring, so there could be species that we didn't collect that kind of fill out this area over here. If we look at the x-axis and do some stats on that, we'll see that yes, the strobing individuals are all the same. The black and gold spider is mimicking its ant pretty well, and the 2 ants are very similar as well. If a predator can't tell apart a tasty butterfly from a poisonous one, the mimic might live to see another day. Historically, such Batesian mimicry has been studied using static museum specimens. However, we know that perception is a dynamic process that often uses movement-based cues. To our knowledge, this is the first instance of a species-specific terrestrial locomotory mimicry that's been found. However, I'm sure there's tons more out there. We just gotta find it. There's a lot more to this study. Hit me up later. I can tell you cool things about antennal illusion, but I don't have time for that right now.